We are tasked to solve for the permissible value p given the allowable member stress of CD, IJ, and CJ. Now to do this, first, we must first get the reaction at this part. Since A is a pin, it has both horizontal and vertical coupon, and G is a roller, so it can only exert a vertical force. Now since there are no horizontal force acting on the truss, therefore AX is equal to 0. And to get AY and GY, we can apply a summation of moment on A or G. So taking moments at A equal to 0, assuming counterclockwise positive, we can solve for GY. So GY has a perpendicular distance of 2, 4, 6, 8, 10, 12 meters, and positive since it induces a counterclockwise moment, and then minus P since it is acting in the clockwise direction, times the moment arm of 4 meters equals to 0. So GY is equal to 4P divided by 12, or P over 3. Now we have GY in terms of P. Now to get AY, we can just basically do summation first vertical equal to 0. So AY plus GY, which is equal to P over 3 minus P is equal to 0. So AY is equal to P minus P over 3, which is just equal to 2/3 of P. Now we have AY in terms of P. Okay, now that we have the forces for the reaction AY and GY, we can proceed with method of sections to expose member CD, CJ, and IJ, and then considering left side for conveniency. You can draw a free-body diagram representing the left section of the truss. So this is the free-body diagram of the same truss we have, and then assuming that all forces are in tension, so that if ever we get a negative value, we can directly say that it's in compression. Now, before we can go on solving for the force members, we need to solve for the angle between for FCD, Fij, and FCJ. So this angle is theta here, which is also equal to this angle by alternate interior angle theorem. And to solve for the angle, we might need to do some ratio and proportion of similar triangles, knowing that this length here has a distance of 3.5 meters. And then this one here has a overall length of 6 meters. By applying ratio and proportion on triangle AIC, we can solve for the vertical distance y. So doing ratio on the vertical distance to the horizontal length, we can solve for y, which is equal to wait, it should be x. That is 2.33 meters. Okay, now that we have the length of y, that is 2.33, we can solve for the angle using the tangent function since we are given the opposite and the adjacent side. So angle theta, tangent theta, is equal to opposite 2.33 over the adjacent side 2 meters. That is theta is equal to arctangent of 2.33 over 2. Which is equal to 49.36 degrees. And we also need this angle here. Let's call it alpha. This is equal to tangent alpha equals to, since this side here is 2.33 and this side here is 3.5, by getting the difference, this height here should be equal to 1.17 meters. So tangent alpha is equal to opposite over the adjacent side, that is 2 meters. Alpha is equal to arctangent of 1.17 divided by 2. that is 30.33 degrees. Now we can proceed on solving for the force member CD, CJ, and IJ. So to solve for the force CJ, we can take moments at this point so that there will be no moment induced by force CJ and IJ. So taking the component of FCD, we can get the vertical component of FCD by using the sine function. That is FCD sine 30.33 degrees. And for the horizontal component, that is equal to FCD cosine 30.33 degrees. Taking moments at this point, let's call it O. So moment at that point equal to 0, assuming counterclockwise is positive. So FCD cosine 30.33 degrees times the moment arm, that is equal to 2.33. Since it is clockwise, this is negative. And then FCD, which is also negative, sine 30.33 degrees times the moment arm distance of 2 meters minus the reaction at the support AY, that is equal to 2p over 3 times 6, and then plus the vertical force P that is given, multiply it with moment arm distance equal to 2, that should be equal to 0. Then factor out CD so that we can represent CD in terms of P. This is equal to negative cosine 30.33 degrees times 2.33 minus sine of 30.33 degrees times 2. That is equal to 2p over 3 times 6 minus 2p. Therefore, FCD is equal to 2p over 3 times 6, that is equal to 4p minus 2p, that's equal to 2p, over negative cosine 30.33 degrees times 2.33. Okay, let me adjust this. Minus sine of 30.33 degrees times 2. That is our force CD in terms of P. Wait, this is not yet the final answer. From this problem, we are given CD that has an allowable stress of 40 kilonewtons compression. So let's assume that CD will yield first. Let's say this is equal to negative 40 kilonewton. Since it is in compression, therefore it's negative. You can solve for P by using our calculator. That's equal to negative 40 equals 2p over negative cosine of 30.33 degrees times 2.33 minus sine of 30.33 degrees times 2. Shift solving, we get P is equal to 60.42 kilonewtons. And this is not yet our final answer because we need to check for first CJ and IJ to see if they could induce a much lesser force than CD. Now that we have for CD, we can proceed on solving for the other force numbers. So for CJ, we can take moments at A, summing forces moments at A equal to 0, assuming counterclockwise positive. Only CJ and P could induce a moment at A. So for P, since it is in the clockwise direction, that is negative, times the moment arm distance of 4 meters. And then for CD, first we need to break down this into its individual components, horizontal and vertical. So for the horizontal component, it is in the clockwise direction, it is negative FCJ cosine of 44.36 degrees times moment arm distance of 2.33 meters. And for the vertical component, that is negative FCJ times sine of 44.36 degrees times moment arm distance of 4 meters equal to 0. And then, manipulating this equation to represent FCJ in terms of P, we get negative 4P plus FCJ times negative cos 44.36 degrees times 2.33 minus sine of 44.36 degrees times 4 equal to 0. Therefore, FCJ is equal to, moving 4P to the right, this will become 4P positive divided by negative cos 44.36 degrees times 2.33 minus sine of 44.36 degrees times 4 meters. Given that FCJ can only induce an allowable stress of 50 kN compression, we can substitute Cj equal to negative 50. So here, we can solve for P. Here we get E is equal to 55.78 kilonewtons. So this is for the force if we assume that Cj reaches its allowable permissible stress, 55.78. Now that we have Cd and Cj, we can now solve for the last force number, Ij. So we can take moments at C, summing of moments at C equal to 0, and assuming counterclockwise positive, only Ay and Ij will induce a moment at that point. So for Ay, 2p over 3, it has a moment arm distance of 4. Since it is rotating in the clockwise direction, this is negative. And for Ij, it is in the counterclockwise direction, this is positive. Fij times the moment arm distance of 2.33 meters equal to 0. And then manipulating this equation, we get negative 8p over 3 plus 2.33 Fij equal to 0. This is 2.33 Fij equal to 8p over 3. Or Fij is just equal to 8p over 2.33 times 3. And from the given, Ij has a permissible allowable member stress of 60 kN tension, therefore it is positive. So Fij is equal to 60 kN. We can solve for P. That is equal to 52.43. Now to solve for to choose which values of P is much safer, we need to choose for the smaller value of P, that is, only Ij has the minimum or most safest value of P, so that Cd, Cj, and Ij won't exceed its maximum stress. So the answer here should be 52.43 kilonewtons.